boy. They're not parallel, they are
Yeah, because
word.
like the basically I think they want you to kind of like write like a here. Yeah, so yes, find two examples. How do you change the definition to be to make it more accurate?
Yeah, we'll do that in a moment.
Yeah,
Okay, I'm
but
sorry. So these are called skew lines.
got it.
Okay. Now to make it more accurate, you would want to say that the lines must be on the same plane. Then
Got
the
it.
then the definition holds, because if they never meet, then they are parallel.
All right. Um, all right. Yeah, I think I got that. Let's see. Let me try to piece together a response for this so you can check if that's kind of accurate to what we're doing here. Yeah, so an example that would be skewed line.
Well, the example that contradict
The
is,
contradicting example.
yeah, is the skewed lines.
That's what I meant. All right, I got it here. I'm gonna take a screenshot of it. Yeah, you elaborate a bit on it, but let me just
Have
get
you
the
have you submitted any written assignments yet to find out how they're going to grade them?
rate like written? No, like
Okay.
as in like
So,
typing in typos yet. No, we
yeah,
haven't done any of them. I
because this is
assume,
your
yeah,
first, and sometimes they just grade for completion. Sometimes they're very strict. We don't know.
sometimes it might look that my teacher might hold it for grading and then they grade it and the grade comes back like a couple days later after then grading it. So I think that's what they'll probably do, considering it's just four questions. They'll probably just hold it for grading and then like manually grade it. All right, I put it in the chat.
I mean, I would probably draw a picture. I mean, and they're called skew, not skewed, just skew. I would really show a picture. I don't know if you can handwrite and scan, but you really want to show two planes.
Um, it
Or
does.
or or another way to do it is with a box. This is the way that, like, this line here, right there, A to B, and line C to D are skew.
I kind of showed like a box, like a 3D
Yeah,
box. Yeah,
yeah. They never intersect, but they're not parallel.
I think you can do that. Looks like you can. Yeah, you can draw it on here. So let me try to draw that box.
What I'm saying is you may want to include a quick sketch before you submit. I mean, everything else looks good otherwise.
Yeah, but does it need to be like any long? Like, do you elaborate more on like the thing here? Is that like or is the,
I'm always less is more, but again, then I don't grade these things. I think that you might want to say what it means for them to be skew. You might say
yeah, I think
that they don't intersect, but that they you know, are not on the same plane either.
intersect because they are not on the same plane. Yeah, yeah. All right. Think they do have the option for you to upload an image or like take a picture of an image or take a photo of something to add to it. Let me see if I
Yeah, I
can
mean,
just quickly.
there's a lot of options. I mean, you can scan something and then snip it into your document. Lots of options. So just try to overthink it. Just, you know, picture though is kind of needed here.
Yeah, could kind of show what the scale, but things that like not being a different plane. So yes, quickly sketch up. All right. All right, let me just quickly take a picture of it there. All right, let me just put the picture here. All right, now I can insert it. There we go. All right. Yeah, I think I'll edit it a little bit later than I'm not adding it in, but
Yeah, let me know if you want
yeah,
to move on to part B.
yeah, we can move on to part B.
Okay. All right. So give an example of an undefined term and how it relates to parallel line. So any in particular that kind of anything stand out to you? Any types of undefined terms?
Uh,
So there it's either a point, a line, or a plane.
well, I mean, if it's parallel lines, maybe like the line and how it relates to like parallel lines. Wait, wouldn't a plane be an undefined term?
These
For
are
that,
they're all undefined. Point,
okay,
line, and plane.
all right, yeah,
Um, so I guess I would talk about the definition of one of them, and
yeah,
then the
I could put
definition of a
line.
parallel lines.
Yeah, I guess that, yeah, that could show how it relates. Uh,
So like, for example, a plane, you can say a plane extends infinitely in all directions.
mhm.
Okay, and then you can just again reiterate that parallel lines, they have to reside on the same plane.
Yeah, that, yeah, yeah, they would be the same. Plane, yeah. Yeah, I guess that kind of shows how they're they're related. Here. Exactly.
You're asking me earlier about, whether more should be written. I think it comes down to like, if you can go find some stuff from your class notes, that might be worth including.
Mm, plane extends indefinitely in all directions. Um, So I put a plane extends indefinitely in all directions to support because parallel lines must be on the same plane instead of just
Yeah,
being like and
and you might also add that it has no depth. I mean, that's one of those other things that you might see from your notes,
extends
or
indefinitely and has well yeah and it just has the width and height or the
I
yeah
guess, and that's where I would probably just go to the notes and see what it says.
yeah
Unfortunately, you're not going to know until you get your grade back, what they were looking for on these.
direction in all directions and has no depth. All right. All right. So So I have the next question here. Yes, I put in the chat.
Yeah, there it is. Got it.
Yeah, it's more like a word problem. Well, sort of.
And Anton will be constructing a segment bisector with a compass and straight edges. Well, Maxim will be constructing an angle bisector with a compass and straight edge. The side similarities and differences between their construction
So
steps.
basically the difference between constructing a segment bisector versus an angle bisector.
Yes. Do you, and this is everything?
Yeah, I
There's
think I
nothing
do
more?
have a, yeah, that's the, and then that below is just a text box, so like, right.
Okay, yeah, I mean,
Ideas and stuff from the notes.
well, it just, I mean,
Yeah, like
there's,
it has like the steps for like,
right. So that's the, it's like, well, what do you think we need to include here? So similarities and differences between their construction steps. Hmm. Well, they're both finding the middle.
yeah, because that's how you, that's what you would need to
Yeah.
bisect anything, so.
You also need to swing a bunch of arc. Um,
You do need to swing arcs in both
I mean, I don't know if they
to
want it.
in an
I don't know if
X
they
like
want,
kind of like you need to swing arcs to the center to make to find the center in both.
right. I
So
mean, right. I mean, I guess one way to do it would be to write out the steps of each and see what is the same. Um, I don't think they're that, I mean, other than the end result is the bisector. The one on the left here, you have to end up swinging an arc and an arc. And you do that. You use the straight edge. You use the straight edge to create the bisector because over here you're going to have the same thing. You're going to, swing an arc and swing an arc for it. Um, I guess I can look and see what the formal definitions of these are.
is contracting segment bisector and angle bisector. Segment bisector. Angle bisector. Looking at my notes, but I don't have anything for. I was thinking for segment bisector, like move back to see if there's something for angle bisector.
I mean, unfortunately, they're not all that similar. So it's really odd, but
Yeah, because but definitely one thing that's similar is they're both finding like the middle of like
yes,
two
that's for
ends.
sure.
Um
I mean, these
yeah,
are the on my screen here, you'll see the construction lines just like I've drawn here. I suppose in some ways the segment bisector is an angle bisector because you're bisecting the straight line into it's perpendicular. Like these are 90 degrees. So in some ways that's similar.
Uh, I guess one of the similarities is that it's the same, like the same distance on either side of the bisector. Because
Yeah, I mean that's just a definition of it.
yeah, like let's see.
You use the same size construction lines on both sides, just like you do in the angle. The angle you use the same size construction lines. That's a similarity.
Both do create two congruent segments. The segments are the segments it creates are congruent for both of them.
It's true. So if you're asking me, I would write down the steps of each differences, and then maybe point out that they both use the ruler straight edge for creating a middle. Uh, they both sort of are angle bisectors in some ways. The straight line gets bisected in half.
Yeah, I guess you could say like the straight line is like bisecting 180 degrees. Have right,
If you want, you could send over another question we can look at.
um, there's this one that just says describe at least two differences between constructing parallel lines and constructing perpendicular lines. Let me put it in the
Okay.
Alright, it's in the chat.
So we kind of already have talked about perpendicular line. The
Yeah, yeah.
perpendicular is basically just bisecting uh,
Uh,
segment. Although you don't have to, you can bisect a lot. You can just do it anywhere. But you do fix points and then you swing arcs.
yeah, you do that in both of them.
Now for parallel lines, you do create a 90 degree. as well. But then you make copy an angle. So one difference is that in the parallel lines is that you're copying the angle.
Yeah.
Um, so after you copy the angle, that allows you to construct parallel lines. So the other, I guess the other thing is you really, with the parallel lines, you have a distinct point. You
Yeah.
have to create some point away from the line, whereas perpendicular lines you just have uh, points on the
Mhm.
line.
Alright. And so would it be that in parallel lines, oh, the points, I guess, aren't,
Well, I'm not
well,
sure.
well,
It's so vague. It's so vague. I'm trying to just give you some ideas. You're definitely
yeah,
copying at
'cause-
an angle, which is not the case over here. You're copying an angle. You're also using a point not on the line. But I guess that's the same as here as well. So I guess you could argue that. Um, so the main difference is the angle. The second difference, I mean, your result is that you have two lines, whereas that don't intersect, but I don't think you can say that. It's in the construction part. The thing is to make parallel lines, you have to do the perpendicular.
yeah, because when you do
Well,
parallel
actually
lines, when you're,
I take that. You don't have to. I take that
well,
back because
you
you
don't
can,
have to, but but you would usually draw a line through the point not on the line. You
right?
would draw a line intersecting.
But let's just say you wanted to be parallel to this. That may be a key difference is if you draw that line and you copy this angle up here,
So like the
if you got,
final thing is not intersecting.
well, I was gonna say is like you don't have to draw perpendicular, I guess is where I was going. If you're looking for a second difference, like you are copying the angle, whereas for um for the one on the right, you have to make it perpendicular. The bisector has to be perpendicular, but this one does not have to be. It can be at an angle.
I don't. Oh, but when she's creating it, she's gonna look at the steps that we followed in the lesson for that. So let's see, for parallel lines, you don't have to intersect G. per- Perpendicular. you do. Another difference, I guess, would also be that mm, like perpendicular lines would create like a 90-degree angle.
Well,
But,
yeah, it's in the construction, it has to be 90 degree over here, whereas it does not have to be over here. You're just copying the angle and it could be 90 degrees or it could not be.
um, yeah, I think yeah, then I think this would probably be fine. Okay. All right. So the next question is number 4.
Okay.
Put it in the chat. All right. So this is yes, it's the last question.
Okay. Right, so Tanya and Pearlie completed a separate proof to show that alternate interior angles AKL, AKL, and FLK are congruent. There we are. Who completed the proof incorrectly? Explain. All right. So notice the give-ins are the same in both. And so the first thing they do is say that so let me start here. Well, let me start with which one is wrong. AKL and GKB, AKL and GKB, those are the angles. Let me draw them here. Right here. So those are vertical angles. That's why Pearl is wrong. So this is actually supposed to be vertical angles. And then the rest of the proofs are the same. So that's the only mistake, is that second line.
So let's see. Roll who? Oh, okay. Well, was in because in statement to angle AKL. Wait 1 second. EKB AKL and angle GKB are not adjacent angles. They are vertical angles. So here's what I said. I just said Pearl's proof was incorrect because in statement 2, angle AKL and angle GKB are not adjacent angles. They are vertical angles.
Exactly. Good.
Right?
That should be sufficient.
So going back to number 2, so the difference between angle bisector and segment bisector. So one of the differences here, so the similarities are that they're finding the middle and there's 2 congruent segments. Differences are that I guess that when you bisect a segment, you get a perfect 90-degree angle. When you bisect an angle, you would not get a 90-degree, or yeah, you wouldn't get 2 90-degree angles. You would get a when you're doing let's see, when you're bisecting an segment, you would get 2 perfect 90-degree angles. When you bisect angle, you would get, you would not get 2 perfect 90-degree. Yeah, I guess so that's what I thought would be one of the uh differences, would be that when you're bisecting a line segment, you get 2 perfect 90-degree angles. Whereas if you're bisecting an angle, you would not get those 2 perfect 90-degree angles by bisecting an angle.
Right.
Let's see. Is there any other similarities? see what other similarities are there.
Sometimes we're trying to find something that just isn't there. There may not be that many similarities.
Yeah, because those are the two main ones. Right, let's see. There's probably other differences. Um, um, let's see difference. I guess when you're bisecting a segment, it would result in a line going there at a 90 degree angle
I guess,
through
I
the
guess, I guess
given
that
line.
is a similarity as they both have lines going through them, although it could be a line segment, but yeah, they both have a line or a line segment going through them as the bisector.
Line. But I was gonna say for the difference of that would be that well, if you're bisecting an angle, wouldn't it be more of a ray that you're bisecting it with, not a line?
I mean, it could be a ray, it could be a line. It really depends. Uh,
Uh,
like you can, but that is a difference, I guess. You could say that that's a line for sure. And this over here is, you could just call it a ray
yeah,
if we're looking for some differences.
bisecting and segment. You would draw a line. But when bisecting an angle, you would draw a ray through from the vertex and point. It's a part. All right.
Got a couple minutes left here. Is there anything you want us to cover again? We just gotta make sure you get
All right.
enough down for each one.
Describe. All right. I think you got the last one down. All right. You got E. All right, C number one or A. Yeah, we got that. All right. I think we got everything. Yeah.
Are you sure? Just to make sure you don't miss something before you submit here.
Uh, we, let me just one second. Let me just clean this one. Right now I have it separated in the word box for a sec similarities. Let me just put it together in a couple sentences. Some similarity varieties are that both find the middle and result in two congruent for two congruent angles. And have actually what we're saying I'm gonna right all right, and result, yeah, perfect. Then some differences are that when you buy this copy paste from here, when you bisect an angle, you get to a angle. Right, there you go. Nice. Another difference is that when just copy paste it from here again. We should be done.
Feel like
Perfect.
you
All
got
right.
everything?
Yep.
All right, excellent. We'll send you notes here shortly in case you want to look at this again, but just trying to overthink it. Yeah, hopefully this is the last of this kind of stuff. Instructions. Moving on to the more
Yeah.
numerical problems.
Yeah. I think the next module is translations and
Good,
transformations, like rotations, that sort of thing.
good. All right, well, that'll be more like your